Behind me you can see a 3D model of the inner city of Gothenburg. As you can see, all those buildings will be constructed newly in the future. Wouldn't it be great if we can reuse the materials from the existing buildings instead of producing all the materials new?
50% of all global waste comes from the construction sector, making it one of the biggest contributors to waste worldwide. If we can find more ways to reuse materials, we can reduce emissions while constructing new buildings. This is exactly what Alexander Hollberg and his team aim to solve with their research.
A lot of waste today is just landfilled. They try to reduce it, but there is no second-hand market yet. There's a second-hand market for clothes. That's really easy. You just go, you pick up an item, it's reused. We don't have this for construction materials.
Alexander and his team are using machine learning to automatically recognize different types of materials. With this technology, they can create a detailed inventory of the materials available in buildings and infrastructure without needing to manually inspect each one. They then store this data in a digital twin, a kind of digital copy of cities, to make it accessible for construction companies so they can reuse materials more easily.
We want to reuse material. The person who wants to use, of course, they want to know if it's a good state, has it the good performance. So with advanced machine learning methods, we can track and find out the states. So how old is it, which material it has on the facade, but also inside the building. If we build up all of this information and store it in the digital twin, we know beforehand how much material will be free in 1 to 10 years. And then this information can be used in design software for architects, so they know which material they can be reused, or for construction companies, or also for waste handling companies to know what to expect in the future and what to do with the materials.
Alexander and his team are utilizing large data sets like Google Street View to collect the necessary data. This approach allows them to gather detailed information about the buildings without having to visit every location in person.
One thing we learned is that relying only on images is not enough, because we have lots of materials that pretend to be another material. So maybe you have something that looks like concrete, but actually it's plastic, or something looks like timber, but actually it's not. So to avoid these challenges, we look at other ways to collect the data.
We are identifying materials. This is obviously a brick wall, but sometimes we identify materials that are harder to detect. I collect raw data. This captures the infrared spectrum, and this is radar. And I combine this data into a machine learning model, and it makes prediction on what the material is.
Accurate data collection to identify available materials will streamline the construction sector's ability to reuse resources, minimize waste, reduce emissions, and pave the way for a more sustainable future.
Construction companies today, they don't reuse as much as they could, because they're afraid of additional costs or the liabilities if something breaks. Now they have to go to the old building, check everything by hand, and then collect this information. So of course it takes lots of time, costs a lot, and it's not done on a large scale. So if we provide such an inventory to the construction companies, where they are sure that they have the information, they could employ this on a larger scale. Yeah, we have so much material around that's still in a great shape. So all we need to do is collect and structure it, and then it becomes natural to reuse it.